Welcome back to my channel. Sorry it's been a while. I've been very busy with university work, but now with the holidays, I have time to make a video. Now, back in part 2 of this series, I promised a Tesla style light show, where the car would party to music. That was over 4 months ago now, and I have been contemplating in my free time how I would pull off such a feat, including making a custom neural network to process music in real time to make the car party to music. Then, one day I was playing Beat Saber on my VR, and I was talking to my longtime YouTube friend Hobson about the difficulty I was facing with designing such a system to do real-time audio analysis. And then it hit me. Why overcomplicate things when I can build a much simpler system to interpret custom Beat Saber levels? Let's make my car party to Beat Saber levels. Alright, so to start things off I created a simple OpenGL surface view which is nested within a fragment UI element based on the already existing renderer code I wrote for my custom Doom port on the head unit. This allows me to draw 3D graphics using OpenGL ES 2.0, which by the way differs slightly to traditional OpenGL 2.0 rendering. In order to control the lights on the car, my idea is to use the blocks in the game to trigger the indicator lights, where a red block triggers the left indicator and a blue block triggers the right indicator. This will be done by using the camera's position in-game to calculate when to trigger the indicator. My idea here is to make the indicators turn on when a block is close to the camera, then turn the indicator back off when the block passes the camera. The blocks will be heading towards the camera at a certain speed which is calculated based on the beats per minute of the music, which is provided by the map data. Utilising the party mode class I created in part 2 of this series, sending commands to the lights is really simple. I simply have to call functions to activate or deactivate any of the lights, and the background thread will deal with sending the CAN frames to the car's network in order to achieve the desired results. Quickly recapping on the frames I sent to the car, this frame allows me to control the fog lights and dip beam lights, and this frame allows me to control the left and right indicator lights, which includes the LED lights on the mirrors. Now I hear you ask, what about these lights? Well, on this car, this is where the side lights are positioned, and unfortunately the frame that controls those also controls a ton of other things on the car. I did try to control them, but the car complained of multiple system failures. Back to the coding, I created a simple test which should draw a single cube to the screen. So, let's open up the app, swipe to the page that we created, and yep, that's a cube. Let's continue. Next, I modified the code such that I could add another cube with a different colour and also make the cubes rotate. Well, there are 2 rotating cubes. Admittedly, I need to move the position of them so one is inside the other, but it's working. Next, I added a movable camera to the world and also allowed myself to place blocks in a 4x4 matrix at a specific Z coordinate. This allows me to create the basic elements to a Beat Saber level. Each block is spawned within a specific X and Y coordinates in a 4x4 grid at a specific timestamp, which is the Z axis in this 3D world. To give the appearance of motion, the camera will move towards the blocks rather than the blocks move towards the camera. Just gonna go open up the app now. And yep, there are a lot of cubes there now, and I can pan the camera around. Perfect. With the basic rendering out of the way, it's now time to load a Beat Saber level. A Beat Saber level is essentially just a zip file containing a metadata file, level data, and the music to be played. I used the Beat Saber modding group wiki for help on understanding the JSON stored within the metadata and level data. The metadata file contains a ton of basic attributes about the map, the name, author, and mapper of the song, the speed of the song in beats per minute, as well as the song file name and level names and difficulties stored within the zip. I then coded a function which allows me to launch a file browser on the Android head unit for me to select a custom zip file. Then it will unzip the zip file and read the metadata file, and if there are more than one level in the map, prompt me to choose which level I wish to play on the car. I then added safeguards to this function such that I cannot select a zip file if either the engine is running or if a level is already playing. Open the app again, and yep, I can select a beat map now with that button. When I press it, it lets me select the level, and then if I choose a certain level, it tells me it's processing it, but currently doesn't do anything. Let's add that. Next, I coded a function to place all the blocks in the world. Blocks are stored in a JSON array within the level data file. Each block is represented by a JSON object with various attributes specifying its type, rotation, X and Y position, and timestamp in beats per minute when it should be hit. I then added the ability for the notes to turn yellow as they hit the camera, to show that they will be played, then disappear once they are behind the camera's field of view, in order to reduce the number of objects being processed in each frame. Then all that was left was to animate the camera such that it moves forward at a constant pace based on the beats per minute of the music. Okay, so the cubes work. They turn yellow as they approach the camera, indicating the indicator will turn on, and the camera moves towards the blocks, in sync with the music. After that, it was a simple process of adding calls to party mode functions, when the block either changes colour or disappears to enable or disable the indicator lights. Since this is England, and it's freezing cold in winter, I wanted to test with the engine running, so that I could have the heating on in the car. Let's just go to party mode, scroll down a bit, there it is, select that, and just make sure it always returns false. And with that out of the way, let's have a look and see how this looks in the car. Perfect, so we now have flashing indicators. Let's now add the dip beam and fog lights to also flash. Lastly, to enable the dipped and fog lights, I created another parser function that reads the lighting events in the level data files. These events are stored in another huge JSON array, and each event dictates which light group is modified as well as when the modification occurs in beats, and the time of lighting event that is executed on the specified light. For now, I am only responding to the back, ring and center lights, as I found via testing that responding to the laser lights made things appear too erratic. For each lighting event, I had programmed each event to be a different pulse duration of either the fog or dip beam lights based on the speed of the music. Since I am running LED dip beam lights, they do not turn on instantly like traditional halogen bulbs do, so I compensated this in code by making the lighting event time 100 milliseconds earlier than what is specified in the map in order to account for this. In order to finalize the light show, I built a simple simulation UI in the bottom right of the display using an Android view boxes. By querying the party mode object using these functions, I can constantly update the simulation UI by checking which lights are currently turned on or off on the car. This allows me to do testing without actually being in the car, using the Android emulator as a test platform. Okay, so now you can see the simulator in the bottom right working perfectly, the yellow lights representing the indicator lights, the top white lights indicate the dip beams, and the bottom white lights indicate the fog lights. After this was completed, I decided to spend an entire day off camera bug fixing and optimizing the entire application, as it was long overdue a code cleanup. Once that was completed, it was finally time for me to record the system in operation. I recorded 3 songs, however, I may also upload various random songs being played by the system if I get enough requests to do so. Since my inspiration for this project came from the Tesla Model X's Christmas party mode, and since it is Christmas, I thought it would only be appropriate for me to feature The Wizards in Winter as the first song to be played on this. I hope you will enjoy the following few performances. Like, comment and subscribe, and I'll see you in the next one. Goodbye from me.